Here is part B of our application problem A3, right, which we started in previous video. So if you have missed that, I'd like you to go through part A of A3 and then get to this, okay? Now in part B, we say the position function of a toy car that moves along a straight line is given by the function s of t equals to t cubed minus 9t squared plus 15t plus 4, where s is measured in meters and t is in seconds, t greater than or equal to 0. Now it says, when is object at rest? Well, I should add here that in part A, we found an expression for the velocity of the toy car, right? So I will add that expression here so that we don't have to repeat that process. Because it says, when is the object at rest? Object at rest means that the velocity is 0, correct? So I will use the expression developed in A3 part A, okay, A3A. So from A3A, we actually get velocity of this toy car is 3t squared minus 18t plus 15, right? So we are going to use this expression to answer our questions. When is the object at rest? So object at rest means Vt is 0, correct? That means Vt equals to 0. So basically we have to find when is Vt 0, which we can find by using quadratic formula or by factoring. This seems to be a simple factoring. Let's factor out 3 first. So we say 3 first. T squared and minus 6t, and this is 15 divided by 3 is 5. Now this could be written as, we need product of 5 and sum of minus 6. So the two terms are minus 5 and minus 1. So we get t minus 5 times t minus 1. When can this be 0? This can be 0 only at t equals to 5 and t equals to 1, correct? So at t equals to 5 seconds and at t equals to 1 second, the object is at rest, correct? Right. When is the object moving in positive direction? That's interesting. Positive direction. One way is when the positive velocity, right? If the velocity is positive, that means Vt is greater than 0. So positive direction is when our velocity is greater than 0. It is in positive direction. Do you see that? Positive direction. So one way is to solve the inequality. Another way, which is very easy, is to sketch it. So let's say we know here our zeros are at 5 and 1, right? So what we can do is we can just plot a graph, right? If I plot approximately a graph, we'll get kind of like this. Is it okay? Because this function is leading coefficient positive, right side up. And these points are at 1 and 5, right? This is 1 and this is 5 for us. So when is object moving in the positive direction? So of course t is greater than or equal to 0, correct? So whenever t is positive, it is moving in positive direction. So don't see as if going down. No, it is positive, okay? This going down means, so this is time and this is velocity for us, correct? It is slowing down. And here it becomes 0 and then it goes into the negative direction. That is what it means at the x-intercept, correct? Now it at this point changes the direction. Do you understand? This is what happens here. So when is object moving in positive direction? The answers are from 0 to 1. Velocity is positive, and then after 5, right? You can say 5 onwards, right? Or greater than 5. So theoretically we can say infinity, right? Okay. Oh, we'll put more, greater than 5 or like this. So it is positive direction, correct? That is one way of looking at it. The other part is part C of A3. I will leave this for you and I'll just give you a note here, add it here for you. I would like you to find displacement. Displacement as after 10 seconds. So first I want displacement at t equals to, let us say, 10 seconds. Okay, and part D is, I would like you to calculate distance traveled. In first 10 seconds. Distance traveled in first 10 seconds. I'd like you to do these two parts on your own. Okay, so I'm not going through the third set of this because it may create a lot of problems, because people are finding it difficult to organize between the two. So I'm adding it to part B. You need to find out displacement at t equals to 10. That is simple. You can just put t equals to 10 here, calculate, get your answer. The second part is distance traveled in the first 10 seconds. This is very critical. Will the distance and displacement be same? No. You're right. It will be different. Now what really happens is, as you can see, initially the toy car is going in the positive direction, right? So if I am kind of draw it here itself for you. So initially what happens, the car for 1 second it goes in the positive direction and then it turns back. Do you see that? It turns back. For 5 seconds it goes in the negative direction. Correct? All this time is going the negative direction, right? And then it goes again in the positive direction. Right? So this happens at t equals to 1. So t equals to 1, and this happens at t equals to 5. So what you need to do is, you have to find first how much distance, what is the position at this place. So distance will be from initial to that point, t equals to 0 to t equals to 1, right? And then you have to calculate from 1 to 5 how much distance it traveled, and then from 5 to 10 how much distance it traveled. And you have to add all the three distances to calculate distance traveled in first 10 seconds. Okay, so go through this problem. It's very interesting and very important from test point of view. I hope you understand. Okay, if there is a problem, write down your comments. We'll give you a solution on this. Thank you.